All right, today we're diving into a topic that has the wellness world's completely split down the middle, grounding, or as some people call it, earthing. You've got passionate believers on one side and some very, very strong critics on the other. So let's get right into it.
I mean, the whole thing really boils down to this one simple question, doesn't it? Can you actually improve your health just by making contact with the ground? That's the big idea we're going to unpack today.
So, just so we're all on the same page, what exactly is grounding? Well, it's pretty much what it sounds like. It's the simple act of connecting your body directly to the earth. You know, think walking barefoot on the grass or on the beach. You can even use special conductive mats indoors to get the same effect.
To really get why people are so into grounding, you first have to understand the problem that it's supposed to solve. And that problem is this idea that we, as modern people, have become totally disconnected from the planet.
So the argument goes something like this. For most of human history, we were always touching the earth. But now, think about it. We wear rubber-soled shoes. We live and work in insulated buildings. We've basically put a barrier between ourselves and the ground. And supporters of grounding say this has created a kind of nature deficit, cutting us off from the Earth's natural electrical energy.
Okay, so if we're disconnected, what's this connection supposed to do for us anyway? Let's dig into the case for grounding and the science that proponents say is behind it all.
This quote, right here, really gets to the heart of the whole pro-grounding argument. The idea is to think of the human body not just as a bunch of chemicals, but as an electrical machine. And just like any sophisticated piece of electrical equipment, it needs to be grounded to work right. The Earth, in this view, is our grounding wire. Now this brings us to the main scientific hypothesis they put forward. It's called the electron transfer theory. The idea is, 1, the surface of the Earth has this massive, basically unlimited supply of free electrons. 2, when your skin touches the ground, you complete a circuit. 3, those electrons then flow from the ground into your body. And 4, this is the really crucial part. These electrons are said to act like powerful natural antioxidants. And to get that last point, you have to know about these guys, reactive oxygen species, or ROS. You probably know them better as free radicals. They're these unstable molecules that bounce around in our bodies, causing cell damage and chronic inflammation, all the stuff we don't want. The grounding theory claims that the electrons we get from the Earth go in and neutralize these destructive little things.
So, if all that is true, what are the results? Well, the list of claimed benefits is pretty impressive. Proponents will point to studies they say show it can reduce inflammation, help athletes recover faster, improve your sleep and mood, balance your stress hormones, and even make your blood less sticky, which would improve circulation.
And you knew a but was coming, right? These are some pretty big claims, and as you can imagine, they have not gone unchallenged. So now, let's flip the coin and hear from the skeptics in the scientific and medical world.
And the pushback isn't gentle. A lot of physicists and biologists don't just disagree with the claims, they say the entire premise is, well, utter nonsense, and that it goes against the fundamental principles of science.
This chart shows you exactly where the two sides just can't agree. The grounding camp talks about a flow of free electrons, but critics immediately say, hold on, our bodies aren't copper wires. We use ions in water for electrical signaling, not free-floating electrons. And to the claim that we're electrically isolated, they just say, no, we're not. We're constantly touching things and exchanging electrons all day long. It's like they're speaking two different scientific languages. This skeptical case keeps building from there. First, they argue there's no known biological highway for these outside electrons to even get inside our cells and do anything useful. Second, our bodies already have these incredibly sophisticated systems for dealing with free radicals on their own. And finally, they really take aim at the quality of the research, saying the studies are often too small, poorly designed, and they point to this telling pattern. The more rigorous the study, the smaller the effect seems to be. And this is where the conversation gets really fascinating. Because it's not just about electrons anymore. It's about a much bigger, more fundamental question. What counts as good enough evidence? It all comes down to a concept in science called the plausibility threshold. The idea is really simple. The more extraordinary and unbelievable a claim is, the more extraordinary the evidence has to be to prove it. And for grounding, the two sides have set that threshold miles apart. Here's how that plays out. The proponents say, look, we already use the body's electrical nature for things like ECGs to check the heart. Grounding is just the next logical step. But the skeptics fire back, not so fast. You're making a claim that seems to violate basic physics. For that, you don't just need a good study, you need a grand slam home run of evidence. We're talking multiple, huge, flawless clinical trials. Okay, so we've heard from both sides of this very, well, charged debate.
What's the big picture here? What are we supposed to take away from all of this?
When you really boil it down, this isn't just one debate, it's two. On one side, you have this really compelling, intuitive idea about reconnecting with nature to find a balance we've lost. And on the other, you have a very firm defense of the established laws of biology and physics as we currently understand them. And that really just leaves us with this one last question. Is grounding a simple, profound health secret that we've just forgotten in our busy modern lives? Or is it a really appealing story that's ultimately based on a misunderstanding of science? As it stands, the debate is still very much alive. And the final answer? Well, it's still up in the air and down in the ground.